Hey guys, welcome to a new video. Today I'm going to open this pack which has water damage. It's from a kid's motorcycle, so it's a small electric motorcycle. You can see that it had some water inside the pack. I don't think it was submerged, but the pack was not properly insulated to keep the water out. I'm going to tear this apart, replace this with cells that I tested, and I will also put these cells back to test. All the cells that looks good and don't have any rust on them can be reused without any issues. So let's start working on this. First I will check the configuration of the pack. From my understanding it's 13S, so let's count the wires. 15, 14. So yeah, it has 14 wires. It means it's a 13S pack. Means there are 13 cells in series. And I discussed with the owner of this pack to actually add one more cell in parallel, because you can observe that it has enough room to get 13 more cells in this. This will increase the capacity. I already smell some lithium, so that's not very good. It means that some of the cells are damaged. But let me cut all the wires. Make sure you don't short circuit. Even if the pack is disconnected, there might be some voltage on these cells. Before taking the pack apart, make sure you take some photos to understand how to put back together this pack. You can reconfigure it, but if your space is limited where you're placing it, you might have to create the same configuration on the pack to make sure you fit it inside properly. I'm going to reuse these balancing wires for the pack that we're going to build, and we'll also reuse the cell spacers, hopefully. You can see that the rust damaged the connections. Right here, some of the balancing wires were disconnected, so that's the main reason I'm going to rebuild this pack. Some of the packs can be fixed without having to disassembling them, but here I consider there's too much damage to safely reuse this pack. This rust here could have got to the cells, and the cells are compromised, and you don't want to be charging such compromised packs, especially when it's more than 1 or 2 cells in this pack. And this one has around 60 cells in the pack, and that's a lot of power, guys. You don't want to be messing with that. If this catches fire, it's quite bad. So the only thing I will be reusing is the BMS and the balancing wires, and also I will be testing the BMS to make sure it functions properly once we mount it back. Right, so this is how they are configured. You see that it goes from here. I will be not doing this because I can short circuit the cells, but I will show you here. It starts with positive right here, and then the strings go positive to negative, and that's the way we are going to repack this as well. So you see it has 5 cells in parallel, and we're going to place another one here, make it a 6 P13S pack. That should deliver around 19,000 milliamps, so 19 amp hours. We'll be using cells that I've recovered from e-scooters. There are 3000 milliamp cells measured on the Megacell Charger. I charge them and discharge them to 2.8 volts. You could discharge them to 2.5 because these are high capacity cells and high current. The one from I think it's Panasonic that makes them, but anyway, they have between 2,900 milliamps to 3,000 milliamps, most of them. But we'll go into the software later to show you how I'm actually placing these cells in the parallel to make sure the pack is properly balanced. That's mandatory, especially when you're reusing cells from different packs, because some of them will have different cycles, and that will cause a difference in capacity on those cells. So when you reuse those cells, you need to make sure you properly balance them in their parallel to obtain a balanced pack. But we'll get into that a bit later. So right now I'm making sure I understand how to rebuild this pack. Let me take 1 or 2 photos. Once I know that I understand the configuration of the pack, I will continue with tearing this apart. Because like I said, I want to reuse the spacers, and I will be also testing these cells to check if they are good to be reused in a different pack. Because I might be rebuilding a pack made from 2 of these damaged packs. So one will be with cells that I recover from other e-scooters, and one pack will be from cells that I recover from this battery. That will allow him to use the motorcycle more and also to keep the expenses down. Be careful when you're using scissors. Make sure you don't short circuit the cells, because that will create some nasty sparks. And also make sure you're wearing protection glasses. You might be wearing gloves as well. Let me put on a pair. Alright, let's keep working on. You see that the nickel is ripping off nicely. That gives us the opportunity to reuse these cells, because some of the packs have very thick nickel and it's welded very well to the battery. It's not a bad thing, but it's harder to reuse those cells. When you see thicker nickel, it means that that pack was made for power, so you could draw a lot of amps from it. But this one has 5 cells in parallel. You can still draw 30 or 40 amps from it, but it won't go at 200 amps, for example, with this kind of thin nickel. So let me show you right here. This kind of damage you don't want to have in your pack. When you see things like this, don't just try to fix it by welding, by soldering some wires to fix the broken connections, because these cells are compromised, and if they're short circuit when you charge them, it could lead to fires, and you don't want that. Even if the BMS have temperature sensors, this one has just 1 temperature sensors, and most of the BMSs will have 3 or 4 temperature sensors, but you cannot cover all these cells or the area where it might get hot. And if one cell gets hot and breaks into fire, then you will have the entire pack catching fire most of the times. So this is not child's play. Make sure you understand the risk when using this kind of batteries, and also when you're repairing them. Don't just charge them without checking the connections, checking the voltages each cell. Don't charge them without using a BMS, because some of the cells can overcharge, and if the BMS is not monitoring it to stop the charge, if one of the cells got to 4.2 volts, then you risk fire. You hear me talking about this a lot. I did not had any issues in 4 years since I started working on these batteries. One of my colleagues overcharged the battery. I told him not to do that, but he placed it to charge and forgot about it, and it got quite hot, but he remembered in time to check it, and we got it out outside, put something on top of it, and we waited until the fire extinguished itself. It was an RC battery, but still, if it goes inside, that smoke is not very good for inhaling. I heard it's very toxic. Right, but if we pay attention, we should be fine. Alright, so one pack is done. After we rip the nickel, the cells will come out. Oops. You saw how fast it glowed, that I got a piece of nickel shorting the cells. Alright, so we removed all the cells from the pack. I'm going to clean my table and continue with the new cells that will be placed inside this pack. So before I'm going to reuse these cells, I tested them like a week ago, and I will be measuring the voltage. I use the Megacell Charger to do capacity test and to also set a store voltage on these cells. So after the cycle for charging, discharging completed, the Megacell Charger is set to store charge them at a set voltage. For me it was 3.68. That was the final voltage. It was set to 3.7, but I saw that most of them will finish to 3.68. And now let's check the voltage on the cells. For 13 For 13S and 6P, I'm going to use 78 cells. So I'll be checking about 80 cells. So you see it's 3.68. The reason for checking the voltage after a week is to see if the cells have any self-discharging. If they self-discharged, then they should not be reused in a pack. It means they will self-discharge in the pack as well, unbalancing the pack. So that's a reason for checking the cells. Let them sit for a week or two and then measure the voltage again. And if you want to be even more precise, you can be using an ESR meter. That will give you the internal resistance of the cells as well. It will give you the voltage and also the internal resistance, which in this case it's 40 milliohms. Anything below 50 milliohms can be used in a high power pack. You see this one is 33. Now that I measured the cells and I know I have enough of them to build a pack, the next thing is to clean their contacts. You can be using a Dremel, but I'm using this file to get rid of the extra nickel on the cells. That will make welding a little harder, and it will spark a lot, sometimes burning through the nickel if it's not making proper connection with the cell when delivering the welding current. It's not very well. So I will get through a quick cleanup, and after that we'll go to the software to arrange the cells in the pack. Alright guys, all the cells are cleaned up, and now it's time to create a new pack. I'm in the Mega CNC software that I developed for the Megacell Charger, and here we'll create a new pack. Call it 613S 6P Moto. Series we want 13, parallel we want 6 cells. I'm going to create this battery, expand it, and now I will begin scanning the cells. Let me select a project. And now it added the cell into the transfer cells window. The reason I'm scanning them and not using directly from the database is because I want to make sure I'm using just the cells I picked from the box. Alright, so I scan all 78 cells that are required for this pack, and I will click Assign. This will arrange the cells to obtain a balanced pack. Alright, so after I assigned all the cells to the battery, now I'm ready to scan them, and that will give me the position of each cell into the pack. See, it highlighted it, and that's the 7th cell. Six. Alright, so the pack is complete now. I thought I'm missing a cell, but it was hidden behind the rest of the cells. Now the pack is properly balanced. In the next step, we'll be laying on the protection covers and we'll start welding the pack. Alright, so it's time to weld the cells in place. The next step is to solder the balancing wires, solder the leads for the BMS, isolate everything together, put some shrink wrap on it, and the pack is ready. So let's get the balancing leads. The order goes like this. We start by connecting the black wire to the negative side of the battery. So this is the negative side. You see it starts with this side, goes around. I will flip it so you can make a better idea on how everything gets together. And we end here with the positive side. And if we want to do a quick test, we can check the voltage between the positive and the negative, and we got almost 48 volts, and that's the voltage we should have if all the cells are at 3.7 volts and we have 13 in series. Right, so let me flip it back. I have the soldering iron ready. Make sure you don't short circuit the cells. Don't do things like connecting both sides, because that will create a short circuit. Be very careful when handling the iron around the cells. So this will be the negative one. So this will be the negative cell. We start here. The second wire goes here. Alright, so let's start soldering the balancing wires now. Start with negative. We then go to cell number 1. Doing this step right is crucial, because otherwise you risk damaging the BMS, or it might not work when you plug it in, because the voltage on the cells will not, because it won't detect the right voltage on the cells. So make sure you go wire by wire. Do this step slow. Make sure you're not in a rush. Don't short circuit anything. Don't burn the wires, and you will be fine. The BMS wires are in place now. I will double check that it goes cell to cell properly, and I didn't skip any wire. It looks good. Now I want to test and make sure that the BMS is working properly. To test the BMS, you can do the following. Set the multimeter to a continuity test. So between the negative wires, these are the battery wires, and between the negative of the connector, there should be no continuity when there's no balancing leads present. If we plug the balancing leads, the BMS should be turning on if it works fine, but I want to check if there's no any water damage actually on this one, because I see some signs that water might have got into this as well. I will isolate the battery now with this cardboard. Let me see where it hinges, right here. Alright guys, so the BMS that was in this battery was broken. It was water damage and it was too much work to try to figure out what was broken, and I purchased a new one. It's 60 amps 13S. It was about 10 bucks a piece. I got two of them. And now everything works fine when I plug in the BMS. Let me show you how to test if the BMS actually works. I had to switch all the wires from left to right because this one had the wires reversed. It starts with B minus and it ends with B plus. The other BMS started with B minus at the top. So make sure if you replace the BMS, check that the wiring is right on your connector. Otherwise you might damage the BMS. So I switch all the wires, and you take a multimeter, set it on buzzer. Default, the BMS should be off when you try to buzz it. What this BMS is doing is it's checking all the voltages on each cell, and if one of the cell is dead, it will cut the power on the entire BMS. It will do the same for charging and discharging as well. So you set it on buzzer, test to see if your multimeter works fine. You see that there's no continuity here. When you plug in the balancing wires, if the BMS works properly and you have proper voltages on your cells, you should hear this. This means that the BMS connected these two ports, and your battery will go live when you do that. So what I have to do now is to connect the wires coming from the battery to the B minus right here, and then I go with the P minus to the external port. Now I solder the P plus directly on the battery terminal. Okay, so this is how the assembled battery looks like. We can test to see if we have a voltage on the terminal now. and here you go, you have 47.9 volts. Now I can place it back in its box. Okay, so the battery is back together now. So the only thing left is to put some silicone here to keep water from entering. Let's test the voltage now to make sure that everything is fine. We have almost 48 volts and this battery is ready to be charged and be used on the motorbike. So that's it, guys. That's the process for rebuilding this battery pack right here. It's mostly the same thing on all the batteries. It might be a different configuration, different number of cells inside, different type of cells, but basically once you understand how to connect everything in series and parallel to get the voltage that this battery was built for, get the right BMS in case your old one is broken, you are good to go. There are more fancy batteries with communication that will talk with different processing units from the bikes or e-scooters, but most of the batteries are built simple with the BMS that works independently, allows charging and discharging depending on the voltage on each cell. Thank you very much for watching and I hope you enjoyed this video. Don't forget to share this, like it and subscribe for more content like this. I wish you the best.